And what I'd like to do now is encourage you guys to check out some problems. We're actually going to check out the problems that are in this left-hand column, these two left-hand columns, you might say here. And you're going to check these problems out with your calculator. Yes, I want you to get out a calculator, and I want you to see what your calculator has to say about these problems. Now, this is an important part of the lesson, meaning that you need to pause the video. Yep, you want to pause the video, get out a calculator, and see if you can punch in some of these expressions. Now, if you're like, okay, I'll try it, but how do I know if I'm doing it right? Okay, just push play, and I'll show you, the first one, and then pause the video again and see if you can get the next one. So get out your calculator, pause the video, and see if you can figure out how to punch in 4 to the 1/2, 64 to the 1/3, and then the rest of them. All right, I see you. You still need to get out that calculator. Now, if you did get out your calculator and you just kind of want to check the first one, that is a good idea, because what I need to do 4 to the 1/2 power is understand how my calculator's exponent key works, as well as the fraction button. For most of you, the exponent key is going to be this caret top key down here. Let's get that to show up a little better. So I punch 4 caret top, and then I definitely want to use these parentheses around the fraction just to make sure that the calculator understands that the entire exponent is 1/2. And it looks like you get 2. So you can do an exponent that is a fraction. Try the next one. Try 64 to the 1/3. Not too hard to do. Just use your calculator's exponent button. Remember, that exponent button is this caret top button. Punch that sucker in there and you get 64 to the 1/3. Now, the whole point behind this is that you guys understand that you can have an exponent that's a fraction, and it actually comes out to be, an actual number. Try the rest of them. Make sure you can punch those in. Eight to the 2/3 comes out to be 4. How about a negative exponent? What happens if you pop in there a negative exponent? Well, first of all, you can do 25 to the negative 1/2. You get this little decimal. I'm going to share with you that this decimal, and if you have the ability, you can change it to a fraction on your calculator, or I'm going to share with you that the fraction for this would be 1/5. And you can write it as 1/5 if you would like. Let's go back now. I'd like to do a little bit more directing you to what in the world is going on with your calculator and these expressions. If you look at the first one, I've got 4 to the 1/2 power. Now, 4 to the 1/2 power, you should notice that 1 is the numerator, 2 is the denominator, and if I go over here, we find out that we can actually rewrite this problem. We can rewrite this problem such that the denominator ends up to be the root. We call that a square root. And the numerator, that ends up to be the power. Looks like what I really have here is like the square root of 4. Well, yeah, the square root of 4, that's equal to 2. It's the same answer. That's because it's the same problem. 64 to the 1/3. Numerator is 3. Numerator is 1. I meant the denominator is 3. If the denominator is 3, that we notice is the same as the root. If the numerator is 1, that's the same as the power. It's like I have 64 to the first power, and then I'm going to do the cube root. Now remember, the cube root of 64 is like 3 numbers that give you 64. 3 numbers that give you 64? That's right, it's 4. That's the same answer. That's because it's the same problem. Are you catching on? Let's do it the other way. The denominator. It looks like the denominator is ending up to be the root. In this problem, the third root. Looks like the numerator is ending up to be the power. In this problem, it'd be like a square. So I get 8 squared. I get 8 squared, which is 64. And then, oh, the third root of 64. Well, we just did that up above. It's 3 numbers that give you 64. Comes out to be 4. Now, you can actually do this problem in the other order. No, it doesn't mean you change the numbers. It just means that you do the radical or the root first. Now, if I do the root first, that'd be like trying to do the third root of 8. The third root of 8 is going to be the number 2 because 2, 2, 2 equals 8. I can do the power second, and, well, look, 2 squared is equal to 4. Now, this last one is kind of interesting because it's got a negative. It's got a negative, but look carefully. First of all, I still have a denominator. The denominator is the root, so it's like the square root. The numerator is the power. Now, it happens to be a negative power, and you guys are going to learn eventually, but we're going to mix it in today, that a negative power is going to flip a problem over. And it flips the problem over, so now it's, instead of the square root of 25 over 1, it's 1 over. It's 1 over the square root of 25. And so we end up being able to think of this as 1 over 5. 1 over 5. So what's going on here? Well, to say it one more time, we have what's known as rational exponents. Now, I don't want this to just be words, like gobbledygook words. Rational exponents, kids, rational exponents are exponents that are fractions. So we have rational exponents. Well, they are the same as powers. Now, the powers are the numerator, so the same as powers, and radicals. Radicals end up being the denominator. So let's see if we can come up with a simple way to remember this idea of having a exponent being a power and a root. So if we have an exponent of the form m over n, so the exponent is m over n, it's always going to be the case that the numerator is the power. Oh, and that kind of rhymes with flower, which would also be like the top. And the denominator is always going to be the root. Oh, sort of like the bottom. So we have a flower power for m, and then we have n being the root. Now the idea is that that is the same as having a power of m, that is a to the m. So again, m is still your power. And then the root, that is the n root, in that position. So an exponent, a rational exponent, m over n, is the same as a power and a root. So how do we actually use this to maybe solve or simplify a problem? Well, if 3 is going to be the power and 4 is going to be the root, then I can rewrite this as the fourth root of 5 to the third power. Now the thing is, I can do some of this, that is simplify some of this, and well, it turns out that some of it I cannot. What do we mean by that? Well, I can certainly do the 5 to the third power. 5 to the third power is really just 5 times 5 times 5. That's going to come out to be 125. But when it comes time to try to do the fourth root of 125, well, that's not going to work out evenly. It just isn't. There's not 4 numbers, at least not 4 nice numbers, that multiply to be 125. But that's okay. Okay, we basically were able to change from a rational exponent down to a more of a root. Again, in this case, a fourth root. But some problems, it turns out if we continue to apply this flower, that is 1 being the power, root, that is 4 being the root, then I can rewrite this as the fourth root of 16. Now it's 16 to the first power, but as you get a little bit better at this, you realize, okay, I don't need to put that 1 there necessarily. Now, can we do the fourth root of 16? Are there 4 numbers that multiply to be 16? Well, with a little bit of thinking, there is. It would be the number 2. Specifically, 2 times 2 times 2 times 2 is 16. Now what that means is that the fourth root of 16 is 2. And this also means that I was able to take a rational exponent and I was able to simplify it, in this case, all the way down to its value. You think you can do 125 to the 2/3 power? Well, this would be a good one to perhaps pause the video and see if you can. If you're not totally sure, then let me encourage you to still start with the flower power. It's always going to be the denominator being the root, so this is the cube root, or the third root of 125 squared. Now, do you want to do 125 squared? I mean, I don't, because that's going to end up being a giant number. Do you want to do the third root of 125? I do, because that's going to be a smaller number. So you can actually do the cube root. You can think of 3 numbers that give you 125. Now, we've kind of seen these numbers off and on. That's right, it's 5 times 5 times 5. So that means the cube root is 5. But we still have the square. We didn't do the square yet. So that means I need to figure out 5 squared. 5 squared, oh yeah, that's going to equal 25. So what we're able to do is turn this rational exponent all the way into a simplified value of 25. A to the m over n is the same thing as the nth root of a, and just to kind of shake things up a little bit, to the m on the outside. Yeah, I can either, like we did with the very last problem, I can kind of do the root first, and I can do the exponent second, or, as you've seen in a few other problems, we can kind of bring the power to the inside and then do the root on the outside. One more thing with this concept, and it's basically going in the reverse direction. Now, going in the reverse direction, or excuse me, not going in the reverse direction, but being able to work with some other expressions. So here, it really doesn't matter that it's 4c minus d. What really matters is that you understand that the 5, as it was on the front, it is on the back, it's the root. The 2, it's the power. And so if I was going to rewrite this problem in radical form, well, it would have to be such that I have this entire quantity squared. Unless I wanted to write it like this, just to be honest, that is kind of nice too. Both of them are the same. Uh-oh, a negative exponent. I told you guys that we would talk a little bit about negative exponents, but we're definitely going to be doing more with them. But listen, a negative exponent, it just means that you end up flipping your expression. So I think you guys can flip that. You just get 2x to the third. You don't really need to write it over 1 because that's the same as just 2x to the third. Now, just so you know, the exponent is now positive 1/2. Don't flip the exponent. Don't flip the exponent, just make it positive. That's what happens The exponent flips to be positive, but, well, that's right. I have a denominator, and a denominator is the same as a root, and I have a numerator, but the numerator is 1, so it's not really going to make any difference if I put the number 1 here or if I put the number 1 here. The truth is, I don't need either of those 1s. I just need the square root. Oh yeah, the square root. So I don't even need that little 2. Now that's one thing I haven't really said today, but it's definitely true that the square root is the assumed root. So we don't record that 2, at least we don't have to record, again, the 2 that is assumed to be that root. See if you can write this in radical form. I know, I gave you a negative exponent. Just think of this as 5x over 1. Because you want to flip and make it 1 over 5x. Can you keep going? Can you write this in radical form? Four is the root. It's the 4th root. Yep, it's the 4th root of 1 over 5x. You can have a fraction in there. And then it's all to the 5th power. We'll write it this way with 5 out on the outside. Now, I thought we were going to do some problems backwards. So as a final piece of this, let's write the answer as a rational exponent. Remember, rational means a fraction. You guys know what an exponent is. So we're going to write these as fraction exponents. Well, listen, it's just going backwards. 4 is the root, 3 is the power, flower power, so that goes up top, 4 goes down below, c to the 3/4. Doesn't get too much easier than that, but it can get harder. Man, we have a fraction. Now listen, when you have a fraction, you have to anticipate that there's going to be a negative exponent. There's going to be a negative exponent, but it's still a flower power. What I mean is that the exponent is still going to be 6 over 3 because, well, that's how it works. 6 is the exponent, or excuse me, 6 is the numerator and 3 is the denominator. Now, I've got this fraction, I've got this like 1 over. I don't want it to be a fraction. I want it to just be 5x. But how do I make it 5x so it's not a fraction? Well, I need to have a negative exponent. So, tricky problem, but basically this negative exponent of negative 6 over 3 is going to be able to, well, it's going to be able to turn my problem back into what I started with. Interesting, though, my exponent could certainly be simplified to be negative 2, couldn't it? Yeah, I can just write this as 5x and negative 2. Okay, again, negative exponents, they cause the base to flip, but they can also cause me to go backwards and sort of flip it back up. Try one. Interesting problem. Is it missing something? Perhaps. Maybe you want to think that it's to the power of 1. Does that make it a little easier to do? Flower, numerator, flower power, denominator's the root. 10 to the 1/6 power. 10 to the 1/6 power. I basically rewrote the problem as a rational exponent. Well, kind of a different lesson today for sure, but we're starting to expose you guys to the next concept with roots and powers. So as we often say, try the homework. Okay, it's the same thing. It kind of has all the different variety of problems that we've done today. We will definitely be using these concepts as we continue talking about roots and radicals.